Hello, fellow tricksters, and welcome to Exploring Coding Boundaries with Low-Key Consulting. Why coding boundaries? It's very simple. We always have to decide. Some code has to go somewhere, and some other code has to go somewhere else. So, let's figure out how to make that decision. And the coding principle by excellence when it comes to boundaries in code is the single responsibility principle. You can look it up online, there'll be some information in the description. The only sentence you really have to remember is the one on screen. A unit of code has one and only one reason to change. What's a unit of code, you ask? Very simple. It's anything that is self-contained at any level. So, a line of code? Yeah, that's a unit of code. A function or a method? Yeah, that's a unit of code. How about a class? Yep. A module? Yep. A code base? Sure. So let's talk about how that works, shall we? To talk about the single responsibility principle, we have to talk about a couple of examples. It's very difficult to talk about it with just one example because it's an example of setting boundaries, and boundaries are very situational. So we're going to look at three different examples. We're going to look at an email regular expression. We're going to look at looking up a student from a CSV file. And we're going to look at sending a password reset email. Let's get started. The first example, as promised, compares two classes that use regular expression to validate an email address. You can see the first one on the screen. The class is called admin, so presumably it is here to validate some kind of admin user of some kind of software. The second class you can now see on the screen. It is called user. It is in every respect the same as the admin class. Other than, it's called user. It has the same email validation, which you can see I took from the same Stack Overflow answer. So let's look at them now together on the screen and wonder, maybe there's a way to extract some of the code, right? That's a natural response. So we have this admin and we have this user. And they are in fact almost exactly the same. So the natural suggestion for someone who's refactoring the code might be, could it look different? And yeah, it can. Let's take a look. The simplest idea is to remove the regular expression and move it somewhere else. In this case, the email validation class. And when we move to the user class, you will see the code is again the same, except of course it's called user. So what's in this email validation class anyway? Is there weird hidden magic? Nothing could be simpler than this email validation class. It took literally only the logic that we removed from admin and user, and now we're using it, and we have a very self-contained object whose job it is to validate email addresses. And the question is this a good idea? Is this the correct boundary for the code? Are we putting the right code in the right place? And the answer is, well, it probably depends. It might be good enough. It also might not. Because here's the thing. If we go back to this code, we have an admin and a user, and they're both validating their email addresses with the same regular expression. So the question here at the heart of the boundary decision is there one and only one reason for the email validation regular expression to change? I will argue that probably you will want to restrict which email addresses can become admin addresses at some point. But maybe I'm wrong. You don't know this. This is a product decision fundamentally. So maybe it's fine to write admin and then user and have the two regular expressions separated. And maybe it's fine to have them both be in a separate module that just does email validation for all email addresses. I probably would leave it as it is on the screen, just because one thing I've learned over the years is that it's easier to bring a code together than it is to separate it. So if I'm not sure whether there should be a boundary or not, I'm often content to leave the boundary there. In the second example, we are looking at code presumably written for a school where we're going to have a roster that will be representing a CSV file as storage. CSV is just comma-separated values. You can look that up if you don't know what it is. The roster is going to be initialized with the path to a CSV file. And when we call it, it's just going to parse that file and create a student object from the row of the CSV file. We will look at the student class next, obviously, to see what that is and what that code does. We can also add a student to the roster, and we can then save the roster back to a file from having it in memory. I don't feel the need to look at the code in too much detail under the save method. The only thing that's relevant is student.toCSV on line 20, because just like on line 9, student.fromCSV, although you will notice one is a capital student, the other one is lowercase student, we are referring to one of these objects, the student objects, and we are leveraging some of their logic to make the roster work. So what happens in the student object? Let's find out. The code for the student object is very stripped down because we just want to get to the example. So you can see here we can initialize it on line 10 with a name, courses that they're following, and a birth date. And we store these as instance variables. And on line 16, we can take a look at making it into an array that fits the CSV format. That is all that this code does. On line 2, we see what is called a class method. That is a method that is called on the student class itself. And its job is to create a new instance of the student object by retrieving information from a CSV row that has been passed into that method. This is essentially the builder pattern, but that's something for later. So how could this code look a little bit different? Let's take a quick look. One of the most obvious changes we could make here would be to strip the student class out of all of the logic that it has that has to do with the CSV file format. The reasoning behind this is that the student object has no business knowing about CSV at all. It's going to have a whole host of other responsibilities in the code, and knowing about a file format, about how to store itself or parse itself, may not be relevant. So what does the roster look like? Well, the roster is a lot more involved all of a sudden. It still initializes from a file, it still parses the same way, but now instead of using .fromCSV on the student, we are inlining the logic. Now a direct result here is that there's nothing at all in the student class that knows anything about the CSV format. Everything is in the roster. Adding a student remains as straightforward as ever, and saving a student now requires knowing in which order to pass the arguments from the student in order to create the correct CSV row. This was true in the other example as well, but in the other example, the student class knew that. So again, which is correct? Well, in this case, probably the second version here, the one you're seeing on the screen, is more likely to be correct. And the reason why is that there is a hard-cut separation of concerns between the file format, that is CSV and everything having to do with CSV, loading from CSV, parsing the CSV, and then saving to CSV, and the internal business logic of the system. In fact, if we wanted to go even further in the separation, we would say that the code we have on the screen has exactly one method that has nothing to do with CSV, which is add student. And that probably there should be a separate roster, which is the internal roster that is responsible for managing the data from its internal representation. We don't have this on call and save, which parse the CSV file and save the CSV file. Instead, we may have a roster CSV object. That object would be responsible for knowing everything about CSV and how to handle it from a business perspective. So it would know how to load the file, it would know how to parse that file into a roster, and it would know how to save a roster back into a file. And again, the responsibility And again, the question we're trying to answer is, what is a meaningful unit of code that has one and only one reason to change? Okay, let's move on to the third example. In the third example, we're joining the big leagues. We're now going to send a password reset email. And that means there's a lot of moving pieces we have to handle. First, let's look at the code that's going to be trying to manage this and make it happen. Most likely, this will be a controller request. That is to say, this is a bit of code that has to handle a request that came from the web. You, or I, probably clicked the forgot password button, typed our email address, and then click send me a reset link. So we're here now, and we have this method called please reset password. And its job is to retrieve information from the request, so the email address we sent, and then send the reset password. And then reply OK, so the browser knows everything is fine. Now, this looks perfectly beautiful, perfectly simple. We're going to have to dive a little bit under the covers of this to see what breaks and where the boundaries aren't respected. So let's take a look at this beautiful, simple looking find the user and then send the reset password email and see what breaks. The user class is pretty simple. It gets an ID, an email, and a password. And it has the send reset password email. The send reset password email method needs to know a couple of things. We need to connect to the database because we need to track that the user requested the password. This is important because we have to disable the old password. We have to do a whole bunch of other things under the hood. So we need to go and activate line 10. User needs new password. Then we need to find the reset password email template, which probably is just a string, but we may or may not have control over that string. It's possible that someone in product or someone in marketing or someone wherever is controlling that string, and we just need to send whatever it is to the user. So we find the template. And then we have to send the email from the email sender, whatever it is, with the template and the user ID. And probably we'll have to put together the user ID with the reset password templates, so it's a friendly message, things like that. Now, this is very, very tightly connected. It doesn't look all that terrible, but there's a couple of things that are kind of bad here. And many of the things you won't realize are bad until you try to write tests for this code. For instance, having the database object here and having the email sender here are both pretty bad because it means they're hard to replace with something else. And one thing you learn is that database tests are very slow. It takes a very long time to connect to the database, change things in the database, check that it changed, etc., etc. It takes a long time. Don't do it as much as you can. Write your business logic, integrate it, and have as few tests as you need, because you do need some. Have as few tests as you need connecting to the database. Another thing is, connecting to the database is actually a very expensive procedure. There are very few database connections available generally, so you want to handle that separately. Now, maybe the database object here is actually going to handle this correctly. Maybe not. We don't know. One thing we also have to know is that database connections are a scarce resource. So we have to hope that the code that you see on the screen now is not irresponsible with that scarce resource. Let's take a look at how we could write this code differently and respect the boundaries of each responsibility a little better. The please reset password method here looks somewhat similar to the old one because it's doing the same thing. We are still getting a database connection. We have to. We're doing it up here now, and largely I'm doing it here because I want to showcase that it needs to be present. In a normal framework, this would be provided for you and abstracted out. So you might have an object available to you which represents a database connection. But it's hard to do with a small example, so this is what I did here. And then we have a new object, the password reset object. And this takes 1, 2, 3, 4, 5 arguments. 5 arguments, and 3 of them are classes. What's going on, you will say? Why are we doing this? Well, there's 2 reasons. But the primary reason is that this makes the code a lot easier to test. And the secondary reason actually derives from the first reason, which is that this is an easier way to handle the responsibility separation. Now, let's go take a look in broad strokes, because we don't need that much more than that, to see how the responsibilities are going to be better maintained here. So what is this password reset object? Let's go take a quick look. The password reset object looks much like what you would expect. It is initialized with all of these objects, and it stores all of them as instance variables. And then when you call the password reset object, what does it do? Well, it finds the user with an email address from a given database. It finds the password reset template and it fills it in properly from a template object, a templater object, which is responsible for doing this. Literally, that is the job of the templater object, is all about creating the correct template. Then we go to the user object and we say, hey, this needs a new password. And we pass the database into that particular method. And what this does is whatever business logic it is. Disable the old password. Create a temporary one. Whatever it is we have to do, right? Generate the link we're going to respond to, whatever the business logic is. And then we're going to send the email from the emailer, and that looks very normal. We have to send it to an email address, and we have to send it with a given body. Now, if we look at this, every single line of code is a different object that has a different responsibility and does a different thing, and they're all very neatly separated. The password reset object is an orchestrator that connects all of these separate objects together, and they all do a different thing, and the password reset object puts it all together. There's another important reason to do it this way. Here we have brought the database sort of out to the surface of all the logic. We see that we're using it a lot. And we're using it in kind of different ways. We have to find the password reset, send the new password, and so forth. Occasionally, if we have to do multiple changes to the database at once, we are going to want to wrap all the database requests in a given database transaction, which is a way of saying everything succeeds or everything fails. And putting everything this way in the call method makes it much easier to do that. So we have now segregated all the responsibilities. We have the user finder. Its job is to find users. We have the templater. Its job is to create an email body from the correct template with the correct information. We have the user, whose job it is to handle its own business logic around all the things the user needs. And then we have an emailer, whose job it is only to send emails. And this will make it a lot easier to know what went wrong as well. If something went wrong with the password reset, you can ask, well, Did the person receive the email? No. Okay, well, let's see if the email went out, right? If it went out, not our problem. If it didn't go out, maybe it's in the emailer. If it's not in the emailer, okay, did we not properly say that we needed a new password? Did that crash and that didn't work? Or did we not find the correct password reset? We can kind of backtrack our way, and that's just one of the ways to debug this. So here, in the effort of answering the question, what's a unit of code? And how do we make sure it has one and only one reason to change? We have created code that is going to be easier to think about, easier to hopefully change, because if we have to change any one of these, it probably won't affect the rest of them, and easier to test. And that's really important because that means it's going to be easier to keep it around for a long, long time. So, in summary, the single responsibility principle says that a unit of code has one and only one reason to change. Hey Tricksters, thanks for watching. If you like this, smash that like, subscribe, and consider donating so I can keep making content for you. See you all next time.